All right. Hello. Good morning. Let's see. I'm just have to make sure I put my face. Okay, let's just keep it there. Let's see. So I made some changes to my setup. I bought like a camera stand behind my monitor, and now I'm actually able to like zoom in properly. So I should have like a nice, what do they call it? Like bouquet behind me and stuff like that. As if that really matters. But yeah, it's cool. Anyways, so what I thought we could do today is that during my vacation, I was listening to some talks about object-oriented programming versus procedural programming versus functional programming. And object-oriented programming is like a subject in itself, because you have like the initial ideas behind object-oriented programming, which is tied to encapsulation, which has kind of completely leaked out in different languages, with classes just allowing you to access any values, inheritance, attributes, and stuff like that. This is just paraphrasing what I've watched, and it makes sense to me. But then we have functional programming on the other side, or procedural programming first. And procedural programming is really decoupling like data from behavior. So you don't have things like classes. You just have standalone functions that receives whatever it needs to operate on. And then you might ask, how is that different from functional programming? Well, functional programming is like even stricter. Ideally, there is no side effects in these functions, and these functions also has guarantees, like they can be composed together, which ties into all these monad stuff and all that shenanigans. But I got fascinated by procedural programming. Like I've heard the term before, but I haven't really reflected or dived into what it actually means. And then I wanted to look at something in our current code base to see what would it look like if we had the procedural approach, because we use React in the client. So React is like very much like procedural, functional kind of. It's definitely not object oriented. But we have other parts to our code base that is very much object oriented. And maybe that could be better if we didn't do that. So what I'm going to do, I'm going to close down this stuff. By the way, I'm super pumped these days. It's so nice to be back after vacation. Like we're doing like really, really exciting stuff now. Things has opened up for everyone. We really know what we want to do with everything we built. What the product should be. There's so many ideas, not just ideas popping up, but people actually building stuff, showing it off. And it's super, super exciting. Anyways, so we're going to use, so this is one of the things that's actually coming soon. It's the standalone application for CodeSandbox Projects, which is also interesting. The biggest struggle for us has been figuring out how the old version 1 sandboxes ties into projects. And we have found something very, very exciting technology-wise that allows us to, like the final release of all of this will probably just be the new CodeSandbox, where you don't think about, you really don't think about how the code is running. Like in V1, it's running in the browser. You just go in and you code. It's all about the code. And then you can tie that code to a repo. And that's basically what we call a project now. And we might still call it a project. I don't know. But the core experience is that you go to CodeSandbox and you just write freaking code. Anyways, what was I talking about? Yeah, so this Electron app is going to be official soon. It's super, super nice. It's just, yeah, I haven't been using VS Code for a long time, and then I had to use it because I fixed a bug related to collaboration, and then it felt weird working in VS Code. Like VS Code is insanely powerful, but it's very low level. Like it's very hard to create a really smooth experience when you have to support so much stuff. And just looking at this, it's so much smoother, and it does exactly what I need it to do for me personally. So yeah, loving that. Anyways, so what we're going to look at, I don't know, I don't want to like sell anyone any ideas on CodeSandbox. I'm just really excited about the stuff. Like now it sounds like I'm selling again. It doesn't matter. Let's see. The thing we're going to look at is Picture Client. Picture Client is object oriented. The thing is a class. Where are we? Yeah, Picture Client is a class that does different things, and basically this is the thing that connects to our development environment and deals with messages. So at its core, Picture Client is really just a connection. And what's interesting is that we have, where is this? Clients. Wait a minute. Isn't this Picture Client message handler? Picture message handler. Oh, I thought, oh. Isn't this where we had the WebSocket thing? Or was that a different place? Sorry, I'm a little bit confused by our, where's the picture connection coming from? Picture Client message handler. Picture connection. Blah, blah, blah. So we have a picture connection. Oh. What was I thinking about? I played around with this. Just let me think. And there was like a WebSocket client. Maybe this has been refactored in the mean. Oh no, wait. Now I know. Sorry. It's actually in here. Sorry, I got a message from my partner. Let's see, a picture here. I think we have it. Yeah, exactly. Sorry. So we're going to start at the consumption level. So what we're doing here is we have this thing called a browser picture connection, which extends a picture connection. And then we and we have a WebSocket client, which is a class in itself, which extends this disposable. And like it's not to make fun of this code. It's just to highlight that it's object oriented. So what we're going to do in terms of the procedural mindset is that we're going to try to think about this connection in a procedural way. Yes. I'm just reflecting on where we should start. I think we should just start with this WebSocket client. Okay, so let's forget about like picture and the connection there. Let's just talk about we have this WebSocket, this connection, this WebSocket connection that we want to create and operate on. So we want to know, let's see here. We want to create a connection where we should be able to know when is it open, when does it send a message, when does it have an error. We want to know if it's connected, if it's connecting, or if it's disconnected. We want to connect to it, which is interesting. you could argue that when you create a connection, you connect to it, which you basically do here, which is funny. Like, we create a new WebSocket when we create the client, and then we connect to it. So this is a bit artificial, because this is not really connecting. This is more like an unconnected promise kind of thing. Yeah. So it just returns a promise that sets up some stuff. We're going to go through this. And then you're able to send and you're able to close. And again, object-oriented wise, this makes a lot of sense. But what would we do if we did it procedurally? So the way I think about this is that we just want to create a WebSocket connection. So what we do is that we create a function for that. WebSocket connection, and the thing we don't know is where to connect. So that would be a string. Oh, sorry. Let's just do export function for these things. So what we need to do is basically what we can do first, at least we can do new WebSocket URL. So what we basically do now is that we say that the connection is of type WebSocket. Like, we're actually returning a WebSocket connection here. What we could do instead is that we could define a type, which could be our picture connection, where we rather said like create picture connection or create WebSocket picture connection. And that would return a picture connection where you kind of map the WebSocket to the specific expected capabilities of that picture connection. But let's just do WebSocket first. Now, what we would do different here is, for example, we have this onOpen emitter, and this is basically an event listener on the WebSocket where we listen for open. So instead of doing anything, you don't need an emitter or anything, we can just export a function on open connection. Let's just call this connection. Let's forget about it being a WebSocket. Let's just call it create connection on open. So this module is basically connection. That's the namespace. So we have on open, and then we take the connection, which is a WebSocket connection. And then we have a callback. And that callback doesn't really do anything. It just triggers. So what we can do now, we can just say, we can have a listener. Well, I guess we can just use a callback, of course. So we say connection, add event listener, open, callback, and then we return a disposer, which says connection, remove event listener, open, callback. That's all we do. So one thing that we already see, which I'm fascinated by, is that we don't need this additional emitter. It just makes sense to use the thing we already have. That's not true maybe for all situations, but here it's quite interesting that we do this. And I think that's a theme of object-oriented programming, is that there's so much connecting things. Especially when you move classes around, you like connect this event to this emitter, and there's like a lot of just connecting stuff together, which I find interesting. But let's do the same for on message, and here we expect that this message should should pass WebSocket data. So now we have to do event, and we have to call, let's see, message. Message, yeah, no let's see, we have to say listener. And what do we actually get there? This WebSocket message event any listener, and we have listener here. And how does it actually deal with messages here? Do we have like on message somewhere? Fire. Okay, so it's just event data. Cool. So now we have an on message handler for any connection. And then we have the same for, was it error? Yeah, let's add that as well. And I guess it should like pass an actual error. So we'll say error. I wonder what it actually, let's see, on error. Oh, okay, so it just fires. Yeah, that's interesting. What does it actually give? Gives an event. Okay, but let's just do the same. Then we'll do listener. We won't actually have anything running here. This is kind of theoretical, just to explore the concept. And then we have things like is connected. So we would again, is connected, give it a connection. And then we would just return the same thing. But we would say connection ready state equals connection open. Oh, WebSocket, WebSocket. And then is connecting. Ready state would be connecting. Is disconnected. Now the thing is, like, the concepts we're doing here, I guess that's closed. These might not make sense when you first think this way. Maybe you wouldn't create functions separate like this. Maybe you would rather we would have a function to get connection state, for example, and then you would rather return that. But doesn't matter. Okay. And then we have send. So we would have connection.send data. And then we have close. Connection.close. Now, and this might seem like completely irrelevant, like why even have this thing when you have to pass a connection anyways. But the point is that there might be more logic here related to the closing. So it's quite simplified now. What's interesting though is that we have all of these things here. Because we want this promise of being connected. And I do wonder, it has a lot of complexity to it. It's quite hard to reason about what this actually means. I'm trying to an open listener on open resolve the promise. Disposable on will dispose. Yeah, so the thing is, like, it's possible to dispose of this connection. And you can argue that you don't really care about that, like, but maybe we should export. Like, there's one final thing here. It's yeah, so that one, and that's interesting. Oh, it's so annoying. I can't listen to music while I do the stream for some reason. Anyways, dispose. Well, you could argue that close is dispose. Well, no, let's be explicit. So we want to dispose of the connection. Of course, we want to close it. But here's the interesting thing. Like, if we just want to get rid of the whole connection, how would we get rid of the event listeners, right? Now we have some lingering event listeners. Some fucking kids outside. Now we are not able to safely dispose of this connection, in the sense that we don't know what listeners are tied to this connection now. So now we put the responsibility of cleaning things up to whatever is consuming this connection. Which is very interesting. So you could say, in one sense, maybe you want to be able to close the connection, but you don't want to get rid of your listeners, because you might like reopen it and keep those listeners around. But if you dispose of it, you want to make sure that these old listeners yeah, it's really, really interesting. You could argue that if you want to dispose of this connection from the outside, you don't call dispose. You just close it and you turn off your listeners if you want to dispose of it. Well, not turn off, but you call the disposers of the listeners. It's hard to reason about without knowing exactly how we're consuming this, but it's where it's not obvious how you would do this in a procedural way. So we're going to make the assumption for now that you need to dispose of it from the outside. Cool. And then yeah, because what's interesting here is, like, if it's, you have to do a lot of stuff. Like, if it's not disposed and it's open, resolve immediately. Fuck, if those kids are waking up, Oscar, now, I'm going to snap. So annoying. Yeah, and if you try to connect and it's already closed, then we dispose and we reject the connect promise. Yeah, so close basically means that it's disposed. You shouldn't be able to reopen it. Can you reopen a closed connection? I don't know. Anyways, Yeah, again, there's like so much logic here, which orchestrates the disposer and the event emitter. And yeah, so you could, like a different implementation here would be that you just, in the constructor, you would like add the listeners and it would trigger the emitters. So we can't argue that doing this procedurally removes the need for this code, because this code is basically the promise of a connection. But it has added complexity because it needs to map to the disposer, or it needs to handle the disposer and the emitters. Disposable. Where is this disposable stored? Anyways, I'm getting stuck in some code I don't think we should do anything about. Okay, but let's imagine now we have this thing. Oops. But what we really want to do, yeah, let's use the logger. What did the logger do? Oh yeah, logger error event. Error. What are you yelling about? Oh, oopsie. What are you? Oh yeah, and this was a event. Okay, cool. Yes, so this makes sense. We don't need this. Now, what's the next step? So this WebSocket client is being used inside a browser picture connection. And this browser picture connection, this does a request to go and grab an instance of picture, and then it connects to that instance. And then we have send and stuff on top of that again. So what we're going to do now, one thing that's also part of procedural thinking is that don't overthink stuff. Don't separate things into different classes, create this inheritance model and stuff like that, which I've been I can't say victim, but yeah, which I've done many times, including here. Like I'm the person who kind of led to doing this, or this even though I haven't written this exact WebSocket client, I'm the one who started this concept of let's make this generic picture connection where you have to implement the connection type. And what we ended up doing, well, we have picture with WebSocket connection. So we added all this complexity that doesn't need to be there. So what we're going to do now, we're rather going to look at this browser connection, and we're going to start being more explicit that when we create a connection, it's not only the WebSocket, it's actually connecting to picture. So what we need to do to connect to picture, and we might simplify this a little bit because it has some old stuff related to it. So as I said, first you have to do a host request to create a connection. Let's just copy that over here. And to do so, we actually need a JWT token. So let's just imagine we get that in here. Let's call it access token. So we don't have to do this. And then what we're actually going to do is we're going to do this thing. This other stuff is old. Let's see. Okay, so we don't need til vet ikke. Den ligger enten i hylla ved siden av TV, i bokhylla, eller i skuffen, roteskuffen på kjøkkenet. Let's see. Okay, so so the thing is, here we're using an abstraction called CodeSandbox Api, which is a really nice abstraction. And what I would argue here is that instead of this being like part of the class, you would just import it. So this doesn't do anything in itself. It's just an API to make requests. So I would argue, how do we actually create that? CSB API, where the hell is that coming from? Private. Okay, so we're actually passing it into the browser connection. Yeah, so I'm thinking two things here. Either CSB API is just a module. You don't have to instantiate anything. It's just a module. But even that said, you don't really need to do this. Like, if we're going to follow this promise of, let's see, let's make this async. Just do what you need to do. You would just do a fetch here. Okay, so we're creating a connection. Yeah, so we don't need URL here. Now we're creating a connection to a branch ID. The URL is actually coming from this response here. So let's say response await fetch, and this is the URL. And I think we're going to drop this picture manager URL stuff, because this is not interesting for what we're doing. It's just a detail. So we have this response. We want this path to be here, and we say method is post, and it's not called data. Is it called body? I guess headers would need to also have content type application JSON. That's what it expects, even though it doesn't pass any data. Yeah, I don't think we need a body here. I think we could do without it. But we have headers. There we go. Okay, so now we have, yeah, I don't think we need to do this either. This is only part of the headers. Okay, cool. And what this returns is an actual, let's see, let's go and grab the manager response here. Can I actually type? No, it doesn't take. Yeah, so I guess the CSB API would allow us to not have to like check the response and stuff. That would be nice. Yeah. Okay. I've changed my mind. Let's. Sorry. There we go. So we're getting a branch ID here. We don't have any headers. We just imagine that CSP API exists. Host, what do we call it? Host manager. Let's remove this. Post. Yeah, of course, now we don't have anything there, but let's just do response, and this is the manager URL. Or it has the URL for this thing. So what we can say here is await. Let's do an async function. And I wonder if we can just say manager response here. Is it typed correctly? Yeah, okay. So let's imagine we have this CSP API as a module. Maybe we can even import it. Import from CSP API. Actually, we are going to create a package out of this that will be available called CodeSandbox Api. Yeah, maybe we can do this. So we say REST. That's nice. Something like that. And we get our response, which is the manager response. So what we can do here now, we can say let picture URL. It's a string, and we're going to do something interesting. We're actually going to put this inside a scope. And then we're going to say picture URL equals response picture URL. Isn't that a string? Oh. What the hell? There we go. Oh, URL. And the reason we create a scope out of this is that we're going to comment this scope, and we're going to label what this scope is about. Get picture instance information. Let's see, and we don't have to call this picture picture details. We can call it picture details, and we can even do this, of course. And then we do manager response like this. And then it's picture details, picture URL. Okay, so now we have that in place. So this is basically just, we're going to create a connection, and to be able to create that connection, we have to do this thing. There doesn't need to be any concepts around it. It's just part of creating a connection. And when we have that connection, yeah, here we see there's a little bit more to this. We have the response. Okay, so let's just go in here, and we're going to copy all the stuff that's happening when we create the connection. We're going to shove that, let's call it VS. And let's start looking at this. So we actually want to do this. So that would be, let's call it manager respond. Manager response picture URL manager token. And now there's nothing like this, but we have something called last activity. So let's take a look at that. So what yeah, let's call it connection for now. Let's call it WS, because I have a feeling we don't want to return an actual WebSocket. We want to return a connection, a picture connection API. So we have last activity. What is this used for? So we could say, okay, so we have const. Hey, Sigurd. Let's see, on open. Update last. I guess we're doing this by maybe we could even compose these things. Let's just call them disposers. And we'll create an array here where we say on open, we give it. Yeah, so this is the interesting thing. Like on open now is a WebSocket connection. How do we think about that? Do we care about that? Okay, let's just call this connection. We should do this in steps. So now the connection is actual WebSocket. So again, so when we're on open, we can do this. When on message connection, we do this. Yeah, so this is interesting. Like on message now, we don't have to do. It's doing two different things. Like you just have like a general on message, and then we update the last activity, and we go and we emit the message. But now we can rather say on message. We can move this to the actual on message function. If we go to on message, and we have the listener here, let's do this. Let's call and let's use data directly. Yeah, this needs to be async. WebSocket message into buffer. Is this coming here from here? WebSocket message into buffer. Cool. Yeah, and I don't think we actually need. I think I saw this, yeah, this circular thing, which is interesting, but I don't think we actually need it. Let's see. Let's just take that. Again, it's like the procedural mindset is like don't prematurely like move stuff into functions. The only place we actually need to do this is here. So we are going to let's see. So if data is instance of blob, then we're going to say await. Let's see, array buffer, and then we have array buffer, but we know it's an array buffer now, so we can just say new uint8 array and await that array buffer, and we rather just call that callback. And if data is instance of array buffer, we just call it with the data. Okay, and if there's an error, yeah, what was the video I watched? I should have it in my history, YouTube history. What was it called? Can I search my log? Procedural programming. Well, it was a couple of them, but I think there was one that, let's see, an overview, never went away. There was this guy who had this rant. Yeah, I can't find it now. But there's there was someone referencing it as their favorite is bad. Yeah, this is the one, I think.
And here I think they're overstating the case.
Yeah, this is the one. I can put it here. This is the one I saw. That inspired to really think about procedural programming and what it would look like. Let's see. Okay, let's just throw an error here. But anyways, the point is that when we get a message, we do want to do this stuff, and we only want to do it here. So let's just do it here. So now you know whatever happens related to getting a message right here. And there is no more code for this. There's no mapping to an event emitter or disposing or anything like that. It's just right there. And then we have a separate on message for updating the last activity. Yeah, and this is just mapping to error. We don't care about that. And then we have this. Yeah, you seen that one? Yeah, it's always good to have these rants, which is like he presents it with so much confidence, which like one have to be a little bit careful when people present stuff with a lot of confidence, but at the same time it makes it more inspirational. It really makes you think about it. And to me, it's just gave me an explanation to what procedural actually means, and it's basically separating data and behavior. Because I've always thought about it's either object-oriented or it's functional, and with functional you have so much, like it should be pure, it should be composable, all that stuff. But with procedural, you kind of get this nice separation, and at the same time, you're not tied to these concepts that functional programming kind of requires to be proper. Yeah, I don't think he went into very much detail. It was basically stating the separation of behavior and data. But there were other examples. I saw some other videos as well. Let's see. And then we have this interval. Okay, so we don't have to check if it's disposed here, I think. Because what we're going to do, we're just going to clear that interval. Oh yeah, so this is the... let's see, we're calling it connection, right? Yeah. So is connecting connection. Let's get these constants in there. So what we're doing here, we're saying time since heartbeat is more than the timeout. We should dispose of the thing. What the hell does that mean? I guess it means we want to close it, but since we in the old code dispose of it, it means that we also remove all the listeners and stuff. Right now we just concluded that that's not the responsibility of this. The responsibility is on the consumer. So if someone creates a connection here, they listen to the close event and then yeah, exactly. It's yeah, exactly. With so much conviction, it's worth you. Yeah, it depends on how you want. Sometimes a lot of confidence. Some people can take a lot of confidence as this person is full of shit and they're arrogant. Yeah, arrogant is the word I'm going for. But I think it should be taken as you just as you say, as a sign of they are really convinced about this. This is worth listening to. The only thing that's important is that you actually make up your own mind and you don't get mesmerized by the confidence. Yeah, that's also true. Yeah. Well, I would state object-oriented programming is bad. It's a bit clickbaity. But the actual content is not, for sure. Let's see. So when time since last heartbeat, I think we can just do connection close here. And then again is connected connection. Yeah, so this is to actually, so this is heartbeat interval. So it can be a little bit more explicit. So what we're going to do here is that we're going to do send on the connection. Heartbeat interval. Yeah, so we have this thing of closing down. So what we're going to do is we're going to do this instead. And then we are going to, let's see, on disconnected emitter. Yeah, so this is the disposer. We are going to clear this interval when we close the connection. That's what we're going to do now instead. So on close connection, we are going to clear this interval, the heartbeat interval. What didn't I have on close? On message, on open. Oh, we don't have, oh, we just have close. Okay, sorry. On close and then close, close. So what we could also do here, we could say, no, nothing. Okay, and the reason I'm putting this disposer in an array it's just to more easily get rid of them. Let's see. So what I'm going to try to do here, I'm going to scope this as well and see if we can do that. Let's see. So I'm not using these heartbeat, Websocket heartbeat. Okay, so we're just scoping the different pieces of creating this connection, which one of the pieces is getting the picture instance information. The other part is creating a WebSocket connection. And then, yeah, so you could argue that we actually create the connection here. WebSocket connection with heartbeat. I'm just playing around there. I'm not like super confident about what I'm doing. I'm just playing with the thoughts and ideas around this. So we have the connection, blah, blah, blah. And then the thing is we want to return this connection. What we could do here actually, oh, this is interesting. You know what we can do? So when we close, we actually go through the disposers. And we dispose. That wouldn't take care of the outside listeners, but it takes care of the inside listeners automatically. So when the connection is deemed done and over, we clear those disposers. Now the question is, what do we actually return from this? What is a connection? Is it the WebSocket connection, or is it something else? So that's what I'm thinking about here, is that we're the thing is that Picture Client has these different pieces of logic to it. And currently that's all tied directly into the Picture Client class. So there is no separation there at all, which is interesting. Like with Firebase, they've gone completely procedural, where you have a bunch of functions that you import and you give it like your Firebase connection, instead of having like Firebase, huge ass Firebase class, and you've had a hard time tree shaking and stuff, which is interesting. That a procedural approach makes tree shaking much simpler. Anyways, Firebase is huge. This library isn't that huge for sure. So you could easily argue that it doesn't matter here. But still, there are very separate parts in this class. Like you do terminal stuff, you do task stuff, you do collaboration stuff, file stuff, Git stuff. Like they have nothing to do with each other. So what would be interesting is that all of these parts, all of this functionality, you just give it the picture connection. It doesn't matter how you created that picture connection. But it doesn't dictate that it's a WebSocket connection. Again, I argued here that we should just return the WebSocket connection, because that's that is the only thing we need, only thing we use anyways. But let's look at the picture connection. So here we have, so basically the only thing we need to do is to send something. We don't really care about anything else. We just want to send something. And we want to listen to messages. But you could easily, let's see, we also have this picture client message handler. How should we think about this? Okay, as I said, what this connection is, it's the ability to send messages to Picture. So an abstraction over that is that even though it's a WebSocket connection under the hood, you're actually making requests. So we have this, I can't remember the name of it, but like every message has an ID. So when you send it in, it can be handled, and then you get a message back, and then you match the ID, and that is the response. That means you can create a promise out of it, even though it runs on a WebSocket connection. So what we could do is that we could actually make that part of the connection, so that we actually return request, Yeah, so it wouldn't even be create connection. It would just be like create requester. But then what about notifications? I have to stop soon. I have to wake up you can't sleep too long. Yeah, maybe we should just talk a little bit how this would progress. Yeah, so what's interesting here is that it was very hidden how that connection is actually made. Because we had some of it was like, okay, we create a WebSocket here, and then we have this connect, which has a bunch of disposable listeners, its own event emitter complexity. And we have this separate browser pitcher connection, which separates the host from connecting to the thing, the heartbeat. Well, that's part of the connection, so that's fine. But converting the message is part of on message instead of sending the message. No, sorry, not sending the message, but like it's separated from the low-level WebSocket client, which makes sense in object-oriented. This is perfect example. So object-oriented, it makes sense that WebSocket client isn't responsible for converting the message into a buffer, for example. That's like more closer to the consumption of the data. But for a developer, understanding this, that this is what we actually want to do, it's very hidden in between like the low-level WebSocket client and this browser pitcher connection, and then you have the main class. Instead of here, you just, okay, I want to send a message. What happens when I receive a message? It's on message. It doesn't matter. But what I wonder is, now we pass in WebSocket here. Well, to be like true to the thinking, it should really be just a WebSocket connection. It really should, because we know that we don't have any other kind of connection. And what would happen then to like the pitcher message handler thing? You wouldn't really have this pitcher connection at all because it is a WebSocket connection. We know that it is. And then you would rather have a concept for dealing. Yeah, exactly. So you would have, okay, let's just code that and then I have to stop. So for a request, you wouldn't have this stuff, like a new pitcher message handler inside the pitcher client message handler. Like this is exactly what he's pointing to in his video. You have these client manager type of classes. So what we would do, instead of having one class dealing with all messages, you would just have a function that deals with a single message. And maybe we can continue that journey tomorrow. I think I have some streaming time tomorrow as well. But let's just do the on notification first. So again, now we're not separating the low-level WebSocket connection from like what's pitcher related. Like the WebSocket connection is what's pitcher related because we do not have any other way of connecting. So we would do on notification, and then we have the WebSocket connection. And what this would do, so we would have notification picture notification. It doesn't return anything. What the hell? Oh, sorry. Go back. So what we would do here, we would say, so we would return on message connection, and that callback would give us some data. And then that WebSocket data would be converted into, do we do that here? On notification, this message handler. Okay, so that would be here. And even this is like 2 different classes and stuff. This is where it gets really interesting. I did the refactor of this right after I watched the video, and it's super interesting what happens to this thing. But maybe we could do that tomorrow. Yeah, let's do that tomorrow. Hopefully. But yeah, I hope I'm kind of at least getting the well, for me this is super valuable what I'm doing here. But hopefully I'm kind of getting the idea across, is that instead of having all these classes taking on their own responsibility at different abstraction levels, we're just thinking of the problem we're trying to solve, and we're just doing it. We're just creating this connection. And with that connection, we want to do different things. We want to send something on it. We want to listen to notifications. We want to know if it's connected or not, when it gets an error, when it's closed. And we are going to use that connection later to actually send stuff as well. So we're going to take a look at that. But yeah, let's continue tomorrow, hopefully. Is there anything happening tomorrow? No, I don't think so. Anyways, thanks for jumping in, and then we'll talk later. Cool. Bye for now.